All right, here we are back again. As promised, another problem using the equations that we looked at for uniform acceleration. All right, so back to our scenario. We've got our lovely girls, and there's 1 and 2, and this one has hair here, this one has hair here. Neither one of them have hands this time. So there is Jacob, and Jacob has slowed down to waving speed, right? And there he is. He's in there, and he's now at waving speed. So there's his hand sticking out the car waving. All right. So so during this whole situation, we have another guy who is also coming up the road, but he is not in a car. This guy is pretty cool, and what he's doing is he's riding a horse, and so how do I draw a horse? Okay. Let's say that there's his tail, there's his back, there's his head, mouth. 1 leg, 2 leg, belly, back leg. Okay, so there's his mane, right? Okay, saddle, and so here's the other guy. There's his legs sticking down there, and there's his arms and his head right there, and he's hanging onto the reins. And so, so this guy's pretty cool. He's got a cowboy hat on, and he's riding a horse now. So he notices that that Jacob is slowed down to waving speed, and Jacob's got this sweet car, right? There's a spoiler right here, and so so this guy right here riding the horse, let's call him Matty. He sees the lovely girls right there, and of course he wants them to be impressed as well. And so he figures that the best way to impress them is to make his horse, whom he calls Slingshot. He's going to make his horse Slingshot go faster than Jacob in his sweet car. And so Jacob, remember, slows down to 22 meters per second. So Matty, when he first starts out, is going 15 meters per second, and that's no slow deal for a horse. That's booking it. But Matty knows that he can actually bring that horse up to a total of 25 meters per second. And at 25 meters per second, he's pretty sure he can pass Jacob. And so he can go faster than Jacob in his sweet car, but he's riding his valiant steed. So let's say that that Matty knows that in order for him to go from 15 to 25 meters per second squared, he needs to go a total of 125 meters. That's going to be the total distance that he needs in order to get there. Okay, so the question is, how long is it going to take Matty to achieve his goal of passing Jacob? Because this is going to matter, because Jacob, remember, he's slowing down, and it took him 11 seconds to slow down. So during this 11 seconds, is Matty going to be able to pass Jacob? If he does this, and it takes him 125 meters. So we got 11 seconds here is the time that, remember, it took Jacob to slow down. Can Matty pass him? And if he passes him, obviously get the approval of the lovely ladies here, and they'll go, oh, wow, whatever. All right, so here we go. So so let's look at this situation. So what do we want to know? Well, we want to know time final. That's our total unknown right here. So what do we know? Well, we know 125 meters is the total distance that he needs. So that's going to be my final distance, right? We know that he starts off here, so that's my initial velocity, and here's my final velocity. So what I want, so I need to figure out, is there an equation that uses initial velocity, final velocity, and distance final, which will allow me to solve for my final time? Well, there is and there isn't. The problem is that just like I had with Jacob, what I need to know is what is my acceleration during this whole time. So which equation might I be able to use to solve for Maddie's acceleration? So if I look at my equations, this one would actually work nicely. My velocity final squared equals my velocity initial squared plus 2 times my acceleration times my distance final minus my distance initial. Now, why would that work nicely? Well, because I know distance final. I know distance initial because we just want to know the time it takes him to go from a starting point to here. So my initial distance is going to be 0. I have my velocity final and my velocity initial, velocity final, velocity initial. And so that leaves just my acceleration. And I don't have my time. So remember in the last one we were able to use the velocity final equals velocity initial plus acceleration times time final because we knew the time. So we could solve for acceleration that way. But this case we don't know the time. That's actually our unknown. So we're going to use this one to find the acceleration. And once we find the acceleration, we can plug it into this one, which will give us our time. All right, so let's see if we can do this. So my velocity final was 25 meters per second, right? And I'm not going to do the units in this because, like I said, that just complicates things. So 25 meters per second. I just said I wasn't going to do the units. Okay, but it's squared. So 25 squared equals my velocity initial. So I have 15 squared plus 2 times my acceleration. That's going to be my unknown at this point, times my, my total displacement, which is 125 meters. All right, so easy enough to solve. Square this, subtract that, divide by this, 125, and then divide by this 2. And let's see, I'm not going to do all that algebra for you. You ought to be able to do that fairly simply, but I'm going to end up, once I square this and subtract that, and I divide by 125, I should end up with, well, let's see, 400. If I divide that by 125, that's going to equal 2a. Divide both of these by 2. It doesn't look like much like a 2. And I'm going to end up with 1.6. That's what I got. So 1.6 meters per second squared. And that's going to equal my constant acceleration. So now that I know the acceleration, of course this acceleration is positive because remember he's trying to pass Jacob. So once I know that, I should be able to throw that in here. So my final velocity was 25. My initial velocity was 15. My acceleration I just found out was going to be a positive 1.6. And my time final is my unknown. So if I subtract 15 from over here, that's going to leave me with 10. So 10 equals 1.6 times my time final. Divide both sides by 1.6. And what do I get? Well, my time is going to equal 6.25 seconds. Look at that. So he's going to have plenty of time to pass Jacob because Jacob took 11 seconds to slow down to waving speed. So Maddie is going to zoom by Jacob, and I'm sure we'll get lots of accolades from the lovely ladies. All right, so there's another equation in this one. The last one that we hadn't used was this one, but essentially all you got to do is check out your situation, see what variables you have, see what you're looking for, and use these equations and interchange them or use all of them. You may use all of them, but eliminate variables if you have 2 variables. So use one to find the other, and then finally plug it in to get your final answer. Piece of cake, no problem.